We're going to continue on in Management 670 Business Analytics with a fast explanation of how to determine if a distribution is normal. So how do we assess normality? Let's get started. How do you know if a random variable is normal? If it's mathematically exact, then we can sign off that way, but most of these values we get from real life come from an experiment, so we then need to have a bunch of data. We can use descriptive stats to look at what that distribution is, but how do we say definitively that this distribution is a normal or close enough to it where our calculations can be used and be precise? Well, it starts off with a normal probability plot, and that plot is a combination of the observed values and then the corresponding probabilities in the standard normal quantile values. It's a mouthful, but we'll talk about it in a second. And then we want to look at that line shape itself. We want to see a nice straight line with the points close to it to be reasonably confident that a variable is or can be thought of as a normal distribution. Here's a normal probability plot of a series of test scores. So they range from just below 50 to just below 80. And I see that they make a nice straight line. So while the x-axis is linear, so you can see 50 to 60 to 70 to 80, the distance between all those groups is the same. Notice the y-axis that starts off at 0.001, ticks up to 0.01, ticks up to 0.05. So we certainly are nonlinear on the left. So we convert the y-axis to those nonlinear values for the quantile. We end up with a nice straight line. Here are the test scores themselves. For 19 of them, I have them ranked from the lowest 48 all the way up to 82. So we can think of the associated cumulative property as 0.05 for each one of the ranks as we increase. So normally a 0.05 would get us to 1.645, somewhere around in there, of standard deviations away. So notice that the normal quantile values are symmetric between, let's see, rank 1 and rank 19. Both are 1.6445, but the sign is different themselves, just to represent how they show up on the line compared to the mean. So that's what we would expect to see. I ran a mini tab breakdown of this distribution, and it looks a little normal. It doesn't peak in the center, but it's symmetric. The mean and the median are the same, but the mode is not. I have some descriptive stats over there, the mean of 65, and the standard deviation pretty close to 9. Also, the skewness right now is 0. That's a nice indication. And a kurtosis of about -0.45. Notice below the associated cumulative property. I'll move the mouse right here. We know that the first quartile is 58. So certainly right here, 0.25 is the level right here. And there's our 58 value. We see some curvature right here. The normal quantitative values are right here. So this is the associated cumulative probabilities right here, and the normal quantile values right here. Both of them are pretty linear. So here's some different examples of distributions. A large value right here would show that if we had a large enough sample size and a histogram that looked like this, you can see that that has all the indications of a normal distribution for number 1. We had a left skewed distribution, so something that certainly is not normal, number 2. You see a peak all the way on the far right, but then we have some outliers on the left kind of dragging that mean down away from the median. And the opposite is true for number 3 in the right skewed distribution. You have some outliers or some far values on the right kind of pulling that mean up away from the median. Rectangular shaped distribution is another way to say uniform. It's kind of a little like what ours looks like, where it has some central tendencies right there, nice part of the middle, but kind of peaks on the sides. So a normal probability plot is usually the best way to determine normality, just quickly. We can see a normal distribution has a straight line like ours does, right there. Starting in the lower left, goes the way up to the upper right. Don't see any patterns of being above or below. It's a nice, solid straight line with an even distribution above and below the line. As opposed to a left skew, see how it starts above the red line right here on the low end? But then as we increase, the observed values actually fall below what we would expect and then come back up. The opposite is true for the right skew distribution. Those observed values are actually underneath the red line and then cross the threshold, systematically stay there for a while, and then duck back under again. Rectangular shaped distribution has something similar itself, but it's much closer to the line. It goes above the line, then below the line. It certainly isn't a nice different breakdown. See how there's not a real pattern here. Most are very close to the line. But you don't get a sequence of too many in a row that are all above the line or all below the line. That's just a fast way, without using Minitab or some calculations, to do a fast check to see if that variable is normally distributed or not, or can be reasonably assumed to be normal without losing too much precision. Thank you.